All right, good morning. How's everyone doing? Happy Friday, and welcome back to another installment of MBF Biosciences short form webinar series called TJIF, or TJ's Information Friday. I want to thank you for joining me again today for the first installment of 2021, and hopefully I'm the last person to wish you a happy new year. If you've attended any of these previous webinars, you might remember me. If this is your first time, I'd like to introduce myself. My name is TJ Tetreault, and I work here in the MBF Labs group, and I do kind of a wide range of things. I do some of the evaluations and demonstrations of our program. I do some quality assurance work, and then I also, I started doing this webinar series. So I'm excited to continue it in the new year, and I'm excited to bring some new and fun topics to the forefront. As you can tell with today's title, we'll be focusing on how to kind of optimize your image and reconstructions for spine detection and how to optimize the classification for those spines. Although these are shortened webinars that we've been doing, they've been pretty successful in my opinion, and that's due to your curiosity and your questions. So if you come across anything that's, you start to develop a question from, please feel free to add or to ask those questions, and I'll go over that right now. Like I said, if you develop a question as the webinar goes on, please feel free to send them in. And submitting those questions is as easy as finding that orange button here, the arrow, to expand your GoToWebinar panel. You're going to find that question section, then you'll simply type it in. Once you hit enter or send, that'll come my way and pop up in my questions panel. And I've been doing this for a little bit, so I think I'm getting the hang of all these questions coming in, but if I don't get to it right away, please forgive me. We have set aside some time at the end for a little question and answer session. So hopefully the last 5 minutes we'll be able to kind of pick through some of the ones that I haven't been able to address as the webinar has been going on. And lastly, this webinar is being recorded and will be available to view later. A link to the webinar will be sent in a following email. So with all that being said, let's get started, shall we? As many of you have seen in previous demonstrations, or if you've seen us at SFN, we have a pretty standard spine image that we like to use. It's pretty basic. It's just a simple branch and a lot of spines on it. But there's been a few requests to kind of expand what we've been working on and show some different things. More specifically, there were a lot of questions about Golgi stained images. So right here we have a very nicely imaged stack, and it's been stained with a Golgi staining. And there's a couple of things I want to point out first off. When we, Golgi staining is always difficult, and it can leave a little bit of smear, and that's something that we see as we click and rotate the image here. So I'll zoom in so it's a little bit more visible, but there's a lot of this kind of gray smear that comes in the Z-axis, and that's fairly typical with Golgi staining. It's a messy stain, but there are ways around this, and there are ways to kind of optimize the image and optimize the reconstruction so that you get the most, but you get the most accurate information out of what you're doing, so you're not wasting your time doing that. Before we jump into that, I have to say that we are recommending, if you are looking to do dendritic spine reconstruction or reconstruction of small things like that, you want to be using a high-powered objective. At a very minimum, it would be a 40x with a high-powered NA, and you want to be acquiring this image stack with Z-step of 0.3 at the largest, 0.3 microns. The reason we do that is because we want to ensure that each spine is getting enough attention from the microscope per plane, meaning we want to make sure that all of these spines have enough time to be imaged and be fully in focus. If the spine is on one plane, on the second plane, and gone for the third, there's not quite enough information to be able to positively classify and accurately be able to reconstruct. There is the opportunity to reconstruct it, but it's more accurate with more information. So that's just a quick reminder for acquisition detail. Back to the optimization of these Golgi stained images. One question comes in about deconvolution, and there was an old deconvolution kind of module with Neurolucida 360 through Huygens. I believe that is no longer applicable, and it may be grandfathered in for some users. But at this point, I don't think we support that any longer. So if I'm incorrect, my apologies. But along the same line, there's a lot of freeware out there for deconvolution, and almost all of those formats that are submitted, or not submitted, but rather produced from those freeware versions of software, those are all, or mostly all, applicable to Neurolucida 360. We should be able to read those in, no problem. So deconvolution is really up to the researcher, whether you want to use it or not. It is an extra step in the pipeline, but it does help reduce some of the blur in your image, and it can kind of crisp up those images that you're working with. Another solution to kind of optimizing the image data is to work with some of our filters that we have. In this example, I'm going to go to the image panel. I'll go to batch filter, and we're opening up our dialog here. It's recommended at this point to start by adding images to filter and selecting from the computer. There have been a couple of issues in the past with selecting the open image. The main thing here is that if you work with the image that's already open, it doesn't quite necessarily have the same logical path to where the file is going to be saved. When we pull it from the computer, we're going to use that image location, and we're going to save the filtered image in the same location, but with the caveat of having an underscore and adding the filter to the name. And I'll explain that in just a second. So here we can see we have the image ready. We don't have any filters applied yet, so we'll go to this configuration section and click on the wrench, and then we'll go to the drop-down list and choose the filter we want to apply, which in this instance is the Golgi filter. Here we can see the output file is going to go back to the same location that we were just in. However, this time we're going to have underscored Golgi added to the name. And that's just a way to quickly refer to that image, and you'll know exactly which one has been run through the filter. We also have the ability to compress the data. And so that is an option for you as well. And this is where things get a little bit more tricky. With the Golgi settings, we have the sensitivity and the edge clearance. And so just to quickly go over those, the sensitivity works in a little bit opposite of what you might expect. The sensitivity is used to control the amount of signal necessary for an object to be selected as a part of the foreground. So with that being said, if you're working with a sensitivity of 100 and you run the image through the filter and it comes back completely white, you're going to want to raise the sensitivity. It seems counterintuitive, but by raising the sensitivity, we're allowing the program to allow more to be kept within that foreground of the image. Similarly, but also dissimilarly, the edge clearance is going to be attributed to the foreground, and it's going to create a sort of barrier between what is going to be considered the background and what's going to get wiped away with this filter. So if you're seeing that your foreground is being cut into a little bit, you can always add more pixels to your edge clearance, and vice versa. If you see that there's a lot of smear still going on and there's still a lot of the background being presented next to your foreground and next to the branches that you want to reconstruct, you can always diminish this value and kind of tighten up what the edge clearance is going to be affecting. To start, it's always recommended to use the default settings. There is no exact answer because images vary. So it's recommended to start with this default value. I'll click OK, and you'll notice right away the status has changed to waiting. This does not mean that it's in progress. This means that it's kind of awaiting our next action, and the only action left to do is click Start. Rather than have you guys sit and watch as the details fill in and we filter through this image, I'm going to use a little bit of movie magic here and grab the image that I've already run through the filter, and I'm just going to drag and drop that into the program here. Neurolucida 360 is giving us the alert that we can only have one image in the 3D window at a time. So I'll click OK. And you'll notice that we've snapped back to the first image. But within this image organizer here, I now have my second image with the underscore Golgi. When I deselect the eyeball icon, and it will automatically flip to the other image that's been opened. And now I can see this filtered image is present. And so very different from the original. If I bring that back, we can see there's a lot of blur. The background is there, and our Golgi staining is fairly dark. If I bring back that filtered image, we can see that the background is really kind of blown out, and that we have the branches are really the only focal point of the image. And as I rotate, a lot of that Z blur has been diminished and removed. So that was a fairly successful run through of the filter. And then the next thing I can do is just work with the image histogram and really fine tune what the image is looking like. What we see on the screen now is it's kind of updating now, and this is something that a lot of users are experiencing at this point with this kind of new build of Neurolucida 360. With this new imaging engine, we don't load the image in at the maximum resolution to start. What we're doing is we're opening it as quickly as we can, and then as you work with the image, you click around, you move, and you navigate. It's going to start uploading and getting that resolution to the highest depth that it can. So if you see a blurry image to start, don't worry, nothing's wrong. Just kind of work with your image a little bit, do some rotations, zoom in and out, and the program will update for you and get that resolution to a maximum. One of the questions that we had was from Monica, and she asked, oops, Monica, I'll get to your question in just a second. One of the questions we also had was from Sarah, and it was about optimizing for Golgi staining versus GFP. The main thing here for optimizing Golgi images, what we're really looking for is we're probably going to want to lower the sensitivity of most of the detections to start, because these Golgi stains are so deep and rich with that saturation, and the background is usually fairly apparent. There's a big stark contrast between those two. So we can always start by lowering the sensitivity, and that's the recommendation that I have. As far as how how transferable these settings are with GFP staining, it depends on how saturated that stain is. So typically those can kind of transfer, but I would say for GFP, you can probably raise the sensitivity up a little bit more back to the default, and you should have a successful time with that. One other question we just received in was, how long does it take to apply the filter? And I apologize, Bruce, but it's not as straightforward as time. It's very heavily related to where the image is located. Always recommended to keep it on the PC that you're working with and not over the network. The next is how big the image is in the X and Y dimensions. And then lastly, how large it is in like gigabytes or megabytes. It can range anywhere from a couple of minutes to a couple of seconds to even longer, depending on how large. So unfortunately, Bruce, it's not a direct answer. To give you an example, this is a fairly small image. It took about 45 seconds to run this through the Golgi filter. So while I was talking, I was kind of working and setting this up. One thing to keep in mind when working with spine data is that obviously we want to be as automatic as possible. However, when we're working with our spine data, it's recommended to really pay attention to these settings. You'll notice that as I showed these seeds, these are kind of focal points for where the algorithm will follow. A lot of these seeds are going to be placed on the spines themselves. That's because Neurolucida 360 doesn't necessarily know the difference between somatic staining, branch staining, and spine staining. It knows the difference between, is there a stain here? Is this background? So it's very important to go through, if you're working with spine data, to go through And on this refine seeds option, you're going to want to remove seeds with your circular cursor. One quick way to do that is to hold down the control key and then click and drag with your mouse. It's going to act like an eraser in Microsoft Paint, if that's still a program that people are familiar with. But it's a really nice way to just quickly go through and remove aspects of the image that don't necessarily need to be reconstructed as a tree. So right now I'm focusing on this large main branch, and I'm going to leave the rest with the seeds on the spine, just so we can get an example of what it would look like without this kind of intervention. The last thing that I had mentioned here, in trace, the sensitivity is at 70. I can bring that down to about 60 just to start. And I'm going to raise the remove traces shorter than to 2.5. This is just something that I like to do. I think it's a little easier to add in these smaller tracings, and it's also going to help remove some of the tracings that would be attributed to these spines because they are so small. The last thing that I'm doing is I'm changing the method. This is a little bit of cheating on my part, but I know that this rayburst crawl method will work the best. So I'm going to go ahead and click trace, and in just a couple seconds, we'll see the result there. The batch filter icon is going to be under image, and then it will be under the tools section. Yes. Okay, rather than going through that, I apologize. I'll come back to the questions in just a second. So like I was saying, we removed all the seeds from the spines here, and we can see that it did a really nice job of connecting all of this, even with the lowered sensitivity from the default. So that's great. That's everything we wanted to see right there. And then if we go on to this smaller section here, we have one tree that has no spines, and then this one. This is actually a branch that's been detected, but it's actually a spine. So what I'm going to do is I'll go to edit, and I'm just going to click on these that were falsely detected, and I'm going to remove them. So now we have a couple of different branches. This area particularly is a little bit hectic, so I'm going to ignore this for the demonstration, but we can always go through and clean it up with our edit function or the user guided mode. Those are two prevalent options that are great for the editing process. Obviously, edit and editing makes sense. What I'm going to do here now is by clicking the show and hide button, I'm really just checking to make sure that the diameter of my branch is accurately represented. The Z-smear here is a little bit challenging, but that's okay. All I'm going to do is I'm going to click on the whole branch, and I'm just going to raise the thickness up ever so slightly so it encapsulates a little bit more, and we'll cut down on some of that Z-smearing. This doesn't have to be done on the whole branch. I could go into the points mode and select the individual points as I see them, and I can also change the diameter there by selecting and then changing the thickness. If you choose one point, you will see the actual diameter here. So if you know the diameter is a specific micron value, you can always enter that as well. So just to continue on, I know I'm rambling a little bit and cutting it close for time, especially at the end. But the next thing I'm going to do is go to spine. And here are the settings that we're going to use. These are the default. The outer range is how far off of the spine are we going to be looking. The minimum height has to do with the base of the spine and how wide that's going to be. The detector sensitivity, as I mentioned, I'm going to lower this because we are working with a Golgi image. And then this is based on the saturation of the staining, and then the contrast between the foreground and background, the contrast between the foreground and background. Lastly, the minimum count. This is a great way to reduce the attribution, that's not a word, the attribution of spines to image noise. So rather than having the data file produce spines on what could be noise or signal, by raising this minimum count, we're going to help kind of reduce that. And so there's a couple of different options for detecting spines. A simple one is just to go ahead and click on the spine itself manually. We'll see that it will compute in just a second and will produce that spine for us. It does a nice job. You'll notice that it is floating, and that's okay for right now. The reason it's floating is because we don't quite have as strong of a signal towards the bottom of the neck where it's connecting. So raising the sensitivity up there would help with that, help remedy that issue. The next way that we can detect spines, I'm going to look at this yellow orangey branch. I'm going to go back and just change the diameter here quickly as well. But the next way that we can detect is click to detect on nearest branch. It's going to use these settings, and it's going to detect automatically in a segmented fashion. So it's not going to look through the whole image. It's just going to look to attribute spines to this one branch. And the very last way is if I were to do remove this checkbox and do detect all. With an image like this, it's going to produce a lot of spines on that kind of section where it's smeared, as we can see here. Because there's signal here on the edge of the tracing, it's going to use that as information where it can apply those spines to. So just be aware of that when you are working with Golgi stained images and when you're working with images in general. If you have stained information there, the program is going to look to attribute that as best it can. So I'm going to just turn this back on. I'm not going to do the detect all. I'm going to click through and have it run on the long red branch that we had automatically traced. And in just a second, we will see the results there. Whoops, I did not mean to do that. My apologies. One thing that I do want to talk about as it's running through detecting these spines is back in February of this past year, we had the privilege of working with Dr. Patrick Hoff's lab, and more specifically, a scientist named Carmen Freire-Cobo, and she was looking at hippocampus and prefrontal cortex in marmosets, which was extremely interesting to work with. I'm going to click the classify all, and you'll know why I'm talking about this after this classification. So all of these spines are now classified with this colorway, and it's based on these settings here. And the reason that I'm bringing up Carmen's research is because she was working in marmosets, and as she was working, she was running through and doing these automatic classifications, and it was kind of producing different classified spines than what she would have done manually. So some of the mushrooms would be considered, maybe they'd be considered stubby, and some of the Philopodium were being misrepresented. So what we worked with her on was she had manually classified a large sample of her own data, over 1,000 spines, and based on her manual classifications, we were able to create a new set of criteria for her spines. And the interesting thing here is that because these ratios are changeable, we were able to find specific criteria here. So that way, based on how she would have manually classified all of those spines, we were able to give 4 values for her, and she was able to run through and automatically classify the spines without having to manually go through and change them. So it saved her a bunch of time. And I think I'm allowed to say this, but the interesting thing here is that not only was there a difference between these settings and the settings that we had applied for her, but there was a difference in the scheme between the prefrontal cortex and the hippocampus within those marmoset data reconstructions that she had done. So a long-winded way of me saying, if you're working with data and the classification scheme doesn't seem to be fitting what's going on here, you are always privy to change this yourself. You can absolutely do that and make sure that these classifications will fit for you and for your work, so that your mushrooms are being classified properly, so that your stubbies, so that your thins and Philopodias are all there, but also that we're willing to work and we're capable of working with a bunch of different data sets, whether you're working in mouse, marmoset, human, rat, you name it, we'll be able to work with it. Another question that had come in was, how do I trace 2 neurons on a single image? How can I separate them and analyze them at different times? So what I'm going to do here, I'm going to cancel this quickly. There's 2 different ways to do this, and I'd say probably the more efficient way to do this. This was from Monica, so let me address this quickly. The best way to do that is probably with this sets tool. Here, we're able to define what we want to create in the set. And as you highlight or create a marquee, you can say placed into set, and we can call this cell 1. And then I can create a second set here and call this cell 2. This is something that I had pointed out in a previous webinar, but I think it's always great to remind. So what I've done here is I've created 2 sets. I'm now opening it in Neurolucida Explorer. And from here, it opened on the wrong screen. But here we can see that as I go into the data set in Neurolucida Explorer, I can click on cell 1, and it's going to have that segmented and ready for analysis all on its own. I can click on cell 2. It'll do the same thing. And we can run through the analysis here. That's super helpful, and that's a nice way to kind of break it out. The sets can be done automatically based on a distance. However, manually doing it when it's something small like this is pretty efficient. The other way to do that is to manually come into Neurolucida Explorer and to draw a marquee. And from here, I'm going to off click on that one. From here, we can again just run the analysis. I can go to structure, branch structured analysis, and I can run these 2 spine analyses very quickly. And we can get the classification, we can get the backbone length, and there is a plethora of information here that we can run through. So I'm not going to waste your time. I'm just going to scroll so that if you return to this video, you can always kind of double check and see what is available. As always, with this data, here we have a density measurement. But as always, when you have your data tables open, you can click this current Windows button, and it will export it or save and open as a Microsoft Excel file. We're running a little close on time, and I apologize for rambling, but there is one more thing that I want to show before I answer a couple of questions. And that is a data set that we were so excited to work with. This data set is an example of expansion microscopy that comes from a collaboration between Dr. Eric Betzig and Dr. Ed Boyden back in 2017. And this is a piece of tissue that was isotropically expanded. My colleague Julie McMullen and I worked on this, and this was quite the project, but this is just a small subset of the data that they had acquired. As we watch the video, we can see the data rotating, and we can see immense detail in the image data. And this is all thanks to the usage of expansion microscopy, as I said. With this, we can get incredible detail without the need for electron microscopes, and this strategy allows researchers to collect information at the nanoscale while viewing it at what would be the microscale. And one thing worth mentioning here, I'll pause the video. One thing worth mentioning here is that us, MBF Bioscience, we had to improve the detection algorithm, and more specifically, how we modeled the necks of spines. Because with this sort of imaging, we get much more detail than we would see with an average image stack. So that's just another way of not indicating, but another way of showing that we're always trying to progress, and we're always working with researchers to try and ensure that you can get the most out of your data. So I'm going to let this just run in the background as I run through and answer a couple of questions before we reach the end of our time today. Oh, one thing to mention here is that we can change the displayed scaling. So if you do bring something like this in, or an image where the scaling is slightly off, we can alter the scaling within the program, and then we can revert it back afterward. And that's something that we had to do here. Please feel free to email me and ask with more detail. I apologize, I'm running short on time, and I can't get into the nitty-gritty of that, but that is an available feature within the program. I apologize. There's a lot of questions coming in. I'll do my best to reach out and answer these afterward, but I know we're close to time. So I just want to thank Dr. Eric Betzig and Dr. Ed Boyden for letting us use their image data for that video. Thank you, Patrick Hoff and Carmen, for letting us kind of share the experiment with everyone. And as always, I'd like to thank you guys for joining me in this short webinar. You guys are always awesome, asking questions during and especially before the webinars start. It's great to come in with some questions and a nice leading path of where I can take these webinars. As always, there's the short survey to fill out once this webinar is done. Please feel free to leave a comment on things that you're interested in seeing, whether you want to have more details in dendritic spines, whether you want to see other programs, or whether you want me to just kind of keep things coming at random. So I do appreciate you guys taking the time out of your day to watch this and to join and for your questions. So thank you all so much for joining. I look forward to continuing the webinar series, and I will be in touch within a week or so to let you know what the next series will be on. But thank you again, and have a great, wonderful weekend.